Okay, so we're dividing polynomials again. This time we're dividing something that has 3 terms, which is on the bottom here. Now with long division, in the last question, they'd already set it up very nicely for us. They had everything in order, and they had a coefficient for every single variable. Okay, so we're going to be dividing the bottom part by the top part. So it's 5x minus 2x cubed plus 3 plus 4x to the power 4 divided by this term here. So when we go to set that up in our way, first of all, we want to always put our terms, our polynomials, in order of the variable with the highest exponent. Okay?
Is there like a reason for that?
That's just ordering polynomials. We just keep it that way to keep everything organized, and especially when we go to do it, when we go to do division, this will make it easiest for us. If everything's all jumbled up, it becomes, I wouldn't say impossible, but very difficult to organize everything. Okay? So we're going to order the bottom, which is this thing here. So the exponent with the highest variable is x squared. Then it's 2x, and then the constant always comes last. And this is the way you're used to seeing polynomials in your textbook. And we're going to be divided into. Again, same idea. This one is x to the power of 4, which is our highest term. Okay, so we're going to draw these out. X to the power of 4. Next, we essentially go down this in order of the variables. So if the highest variable is power of 4, we need to have power of 4, power of 3, power of 2, power of 1, and you could say power of 0, but essentially the constant is what we're talking about. So we have x to the power of 4 minus 2x cubed. And then is there an x to the power of 2?
No.
No, the next one is to the power of 1. So we don't neglect that. Because this is also ordered this way, we have a 2, 1, and you could say 0. We need this to be in order and going down by a power of 1 each time. So what we do is, because technically power of 0 means this doesn't exist, whatever this value is will be 0 and it cancels itself out. So we could say it technically exists as the coefficient 0. So we plug it in so that we're dropping by 1s in powers, just like we were doing with the division of the other one. Okay? So after we have that, we have plus 5x to the power of 1, you could say. And then finally, our constant term, which is 3. So now that we've set this all up, we're able to do the long division. Okay, this is very important for setting this up. And even in synthetic division, we're going to set it up like this. Okay, this one is the same idea. We take a look. Coefficient. Our coefficient is 1. Well, what's our coefficient in the first one?
1.
1. Okay, so we know we're going to be multiplying by our 1 term. Now, because there's 3 terms, we have a trinomial here. Think of it like we're dividing into the first 3 terms. So whatever our term is that we're going to multiply these all by goes above the 3rd term. Okay, you could say it like that. So in this case, what are we multiplying x squared by to get x to the power of 4? X squared, because our coefficient is still 1, and I'll write the 1 in there because it won't make a difference. And then x squared times x squared will give us x to the power of 4. So that's what we're multiplying all of our terms by. So underneath, we're going to get x to the power of 4, so we can now subtract that. And then x squared times 2x is positive 2x cubed. And see what this does, oh sorry, we'll see the last one. And x squared times 1 gives us x squared. And what this does, when we go to do the division, we can actually subtract, because we have powers of 4, those are like terms, cubed or cubic functions, which are power of 3s, they're like terms, so we can subtract them, and squared. If this didn't exist, this squared would go under here, and I can't collect those like terms. And then I start ending up with a funny looking division question. Okay? So we now go to subtract. And I'm going to zoom in to do this actually. Our first terms are the same. So x to the power of 4 cancel out. Next we have negative 2x cubed minus 2x cubed. That's going to give us actually 4x cubed. Are you okay with that?
Yeah.
Okay. And then 0 subtract 1 is going to give us negative 1x squared. Okay. Then we bring down our next term, because it's a trinomial, plus 5x. And now this is what we're dividing into. We're taking our 3 terms here to go into this. Same idea. Our coefficient's 1, so what coefficient do we need to get to negative 4?
1.
Not quite. What do we multiply?
Negative 4?
Yeah, that's right. We multiply by negative 4. And then because it's x cubed, what do we multiply x squared by? X. Yeah, to the power of 1, you could say. So now we do the exact same idea. We take this 4, or negative 4, and multiply it by each 3 of these terms. Okay? So, there we go. We'll get negative 4x cubed, and then negative 8x squared. That's negative 4x times positive 2x. And finally, negative 4x. Okay? We go to subtract these 3 terms. Negative 4x cubed cancels each other out. Again, we're subtracting. Okay. Negative 1x squared minus negative 8 is like adding 8, so we get positive 7x squared. 5 subtract negative 4 is like adding, so it's like plus 9x. Okay. And finally, we bring down our third term. And again, we have our trinomial. Is this making sense so far? So what term do I need to multiply to get the 7x squared?
7.
7, that's right. I'm already at x squared, so we do positive 7 as our next term. And we're going to get 7x squared when we multiply, plus 14x plus 7. Okay? So, we finally subtract these terms. These guys cancel out. This is a subtraction question. 9 subtract 14 is negative 5x. And 3 subtract 7 is negative 4. So, what this is now is there's nowhere else to go with this. And also remember, this is a power that's less than the greatest power we have over here. So we wouldn't be able to even divide this into here. So this is kind of when we know we have our remainder. This is what our remainder is going to be for this question. So when we go to put it all together, have they done that? Yeah, good. When they go to put it all together, I guess we need a little more room. I'll zoom out a little. So we're going to write this question together. We have is equal to x squared plus 2x plus 1. And then what's on top here, which is our x squared minus 4x plus 7. And our remainder is the last part of it, negative 5x minus 4. Okay, so we put our what we divided by into a bracket, what our new answer is into a bracket, and then we leave the remainder outside of those brackets. Do they want us to factor that any farther? No, they just wanted us to work with the division of this. Okay, and of course we could use the rainbow method, take all 3 terms, multiply them by all 3 terms, and then to check our answer. Let's go on the assumption that we're okay for this one. Okay, so that's the long division when we're missing terms and they're out of order.